This is not a full lecture, just a quick introduction to soil texture by feel. And so here is the soil, oops, stop. This is the soil texture by feel page. I will add this video I'm doing now at the beginning, but soil texture by feel is a way to do it just with water and your hand and a chart. And it's harder than it sounds, but with a little bit of practice, it's not that hard, but it does take a lot of practice. And the three things that you really need to understand: the feel of sand, silt, and clay is distinct. Sand is very gritty and it feels rough and gritty. Even very fine sand is gritty to a sensitive feel in your fingers. It just feels rough. Something's in there. And we organize the sand, silt, and clay soil particle sizes, which are nothing more than rocks that have broken down into smaller and smaller pieces. The rocks break down into smaller rocks, they break down into pebbles, they break down finally into sand, which is a rock that is broken down small enough to fit through a 2 millimeter screen. So if it's 2 millimeters in size, it will fit through a 2 millimeter screen. We now call it part of the soil. It is now sand and it feels gritty, very gritty if it's 2 millimeters, but it's still gritty even at the smallest sand. You feel something there. It's like this is still gritty, even though the grits are very, very small. The next size, once it leaves the realm of sand, it becomes silt as it breaks down into smaller and smaller pieces still. And silt feels more like a flour. If you've ever felt flour, not corn meal, but wheat flour, baking bread and using wheat flour, and it feels kind of silky and smooth. That is the type of feel you get with silt. And silt is something you get a lot of with water movement. The sand tends to collect, the silt moves down to other areas further away from and separated from the sand because it's lighter and easier to move. And the clay takes very long to settle, and so it moves even further in water. And so silt separates out from the sand and the clays frequently with moving water. And so when you get soils that are formed in areas where lots of silt is built up, it feels smooth. Clay are the tiniest of particles. They are so small that the materials, the minerals that made up the rocks have gone through chemical rearrangements. There's a lot of not only physical breaking down to smaller pieces, but also chemical rearrangements of the minerals, the atoms that make up these particles that once were rock. And the clay are microscopic or submicroscopic, very, very tiny, but they are the most important when it comes to holding on to water. They've got so much surface area because there's billions and billions and billions of them just in a tiny amount of soil. And each one of these little clay particles can be surrounded by water molecules. And all of that water can contain nutrients, the nitrogen, phosphate, and potash or potassium that plants need, plus the other nutrients that plants need to grow. And so clays tend to really hold on to things. And there are also lots of charges, negative charges mostly, but positive charges too. And these charges hold on to water and hold on to nutrients. And clay, because of its extremely small size and its extremely uh, good ability to hold on to water, they might be slick when you rub your fingers back and forth, but slick and smooth are not the same thing. It doesn't feel like flour. And when you pull your fingers apart, it's sticky. So clay is different, it's sticky. And again, that's a property of it being so small with all of these charges, it becomes sticky when wet, or at least moist. If it's too wet, you can't feel the stickiness. So what do? We want to know what is the percentage sand, silt, and clay so we can look up the texture of that soil. And so you watch the video below down here, and where did it go? Here's the file I'm looking for. But when you watch the video, you're going to go through this chart, which is also available there. And you start by taking the soil and trying to uh, roll it into a ball, and then you squeeze it out with your thumb to make a ribbon. And if you can't make a ribbon, it's sand. You just call it sand. And the only one that's not on here is pure silt. Clay is on here. Sand is on here, but pure silt is not on this list. I've never found it myself in nature. It's always been artificial. Silt is almost always mixed, at least some, with something else, unless you've done something to try and separate it out. It's always a little something. And so once you determine, can I make a ribbon? If not, it's sand. If it is, well, then I have to say, how long of a ribbon can I make? Can I make a short ribbon? Can I squeeze it out and make a short ribbon before it breaks off? Can I make a medium ribbon or a long ribbon? That's part of what takes practice. Once I know short, medium, or long, then I have to put a little bit in my hand and go, does it feel smooth, gritty, or neither smooth nor gritty? And you just follow this chart. And there's 9 different textural classes here out of the 12. There's, I can't even make it into a ball. It's sand. I can make it into a ball, but I can't make it into a ribbon. It's loamy sand. So that's 11. The 12th one that's missing is pure silt, or virtually pure silt. Okay. And here's the soil textural triangle. And just look at the video. And if you want, you can grab a little bit of soil, make sure it's something that's safe without anything that's either potentially going to get you sick or chemicals or something. But if you have a source of clean soil, try it. Watch the video and give it a try. Normally we would be doing this in the lab, but we're not going to have the opportunity to do it in the lab. I'm not going to have you doing a specific lab where you have to do this. There's too many questions that might need to be answered. And having done this with students many times, I just don't feel that it's something that is going to be effective to do on your own. So if we're in the lab, great. We can play with soil texture by feel, and it's a good thing to play around with because it's quick and easy once you're practiced to get a rough estimate of what kind of soil you might be working with. If we're not in the lab and we're doing this online, the video will suffice.